In this video, we're going to take a look at the HR diagram activity. So there's a little bit of an introduction here, which you can go ahead and read. I'm going to walk you through the steps so you can see each of the pieces. You'll want to go back and do the work yourself so that you can answer each of the questions along the way, though. So for this particular lab, we're going to be using Google Sheets some more. There'll be one sheet that you'll need to access and make your own copy of, and then a second blank sheet just for you to record your results for an earlier part. So to start, make sure you make that blank spreadsheet as described here. If you haven't already gone through and installed Flash or downloaded the specific simulations we're going to use, you'll want to go through and do that, because one of the first things that we're going to do is we're going to utilize the Blackbody simulator. So when you open the simulator, you'll see something that looks like this. I'll go ahead and click over to it. Sometimes it can take a bit to load up. That's fine, you can give it time. And what we're going to do is we're going to pick 4 or maybe 5, let's see. Eventually 5 temperatures. First you'll want to go through and play with it. So there are some bits and pieces to play with. First thing is you want to click over to the Filters tab. So what this is showing us here is when we use telescopes and take images, we put filters in front of the cameras when they take the image. So our camera is essentially a black and white camera, and the way that we can get color images out of it is by putting various different filters in front of the camera, taking pictures, and then combining the pictures into a color image after the fact. So we have multiple different filters that we use. The R filter covers a lot of the red range. That's this one right here. So any light that corresponds to this range is part of the R filter. There's the V filter, which is the green one. So you can think of that. It stands for visual, but some people like to think of it as verde, so it reminds them of green. The B filter for blue, and then the U filter for ultraviolet. So your very first questions will ask you to look at what's the wavelength range for these filters that we're going to go through and use. And the next part is that you're going to go through and pick 5 temperatures. You can either use the slider here to change temperatures, or you can type directly into the box, press enter to change the temperatures. You're going to pick 5 different temperatures, and you're going to record the magnitude of the light that comes in through each filter. So you can read a little bit more about magnitude. There's a link in the lab itself. But magnitude is just another way of describing how bright an object is. So by saying the magnitude of a specific filter, we're talking about how bright is it in that particular filter. So how much light of that color are we getting at? So when we use the capital letters here, that means we're talking about the magnitude in the U filter, for example. So you're going to go through, answer the questions about the B and V filters. Then you're going to go through and pick your 5 temperatures. And you're going to record in your spreadsheet those 5 temperatures that you're using. And then we're going to look at the color index B minus V. So what this is B tells us how bright something is in the blue. V tells us how bright something is in the green. And so when we subtract those two, it gets us an idea of the color, true color of an object, which also can tell us something about temperature. So we can use it as a proxy for temperature for the various different stars. Now, one thing to note about magnitudes is that the more positive, like the bigger the positive number you have, that means the dimmer the object. So something that is a very tiny number, or even negative, means that it is brighter in that particular filter. So we can take a look at this, and you'll see this a little bit when you go through and look at your various different temperatures. So right now we're at 6,000. So if I were to take a look at how bright that is in the U, that's a magnitude of 5.65. If I change this to 3,000, we expect it's not going to be as bright. So I would expect that number to get bigger, and we see that it did. It went up to 13. So if I want to see something really bright, we'll see that it'll actually turn negative in there. So the more negative or smaller the number is, that means the brighter something is in that particular wavelength. So you're going to record this B minus V color index here and make sure you change it to B minus V for each of the 5 temperatures that you're going to go through and do. And then you're going to use that to create a very small scatter plot. You don't need to go through and do the send to sheet for that particular plot. You can just view it in a little small side window. So you're not going to end up sharing this or anything. It's for you only so that you can describe the relationship that you see once you go through and create that. So that'll give you an idea to think about why we use the B minus V color index and how it relates to the temperatures of the objects, because we're going to use that as a proxy. So we want to make sure we understand how they relate together. Then we're going to start looking at star clusters themselves. So there's a link to the spreadsheet both in this manual and in the Canvas page assignment as well. So that spreadsheet looks something like this. When you first get to it, you'll see this pop up, which is just reminding you that you need to make your own copy to be able to go through and edit it. So we'll click OK, make a copy, and I'll just stick it there, that's fine. So now we have our own working copy of the spreadsheet. So you'll notice a few different columns here. RA stands for right ascension, and DEC stands for declination. So we've got right ascension and declination. These are like the latitude and longitude of the object in the sky. So each one of these is corresponding to a specific star within the cluster called M67. So that's the name of the tab down at the bottom. And you'll see that we have 4 different clusters here, each with their own name. And since these stars are all in the same cluster, that means they're all in the same, for one cluster, all the stars are in one particular spot of space. So you'll notice that these RA and DEC numbers don't really change that much, and that's because those stars are very close to each other. Then we also have the B magnitude listed here. We have the V magnitude listed here. This is B minus V, so that color index that you looked at before. And then this one is actually negative V, which you may or may not want to use as you go through this, but it's the exact same number here, just made negative. So we should really say something like minus V, but I can't change the main one, so just know that that's what that means. So we have this data for 4 different clusters. They don't all have that minus V column because we really don't need it. And then the very last one corresponds to some images. So these images are B minus V at the horizontal axis and then V on the vertical axis. And again, the smaller the number or more negative, that means the brighter. So the brightest things are up here, dimmer things are down here, and then B minus V along the horizontal axis. And that's the same for each of these 4 clusters. So this is the structure of our HR diagram. And if you need a refresher on stars or HR diagrams, because it's been a while since you've been in lecture, or if you haven't gotten to it yet in lecture, then there's an intro video in Canvas to give you a bit of a refresher or a quick overview of this topic so you understand why we're looking at these things. So we've got each of these dots represents 1 star, the star in our data sheets for each of those tabs. And so we're going to utilize these pictures to help us answer the rest of the questions in the lab. So they're going to have you start with the final tab, the cluster image page, which will have you answer some different questions about them. Again, most of these you'll need to refer to that review video. There's also a little bit of a review if you click here as well, but this is more text-based, so depending on whether you prefer videos or text, that's fine. You'll need to use Google to search to figure out what the absolute V magnitude and B minus V color for the sun is, basically so you can figure out where does the sun fit on these graphs, so you can get sort of a reference point in there. There's some more questions here about how stars go through their time. So again, there's a few more videos if you want some video refreshers. You can also use the textbook to go through and refresh things. And lastly, we get to a movie. So this movie shows how the HR diagram sometimes also called color magnitude diagram, which is the language they're using in this lab, changes over time. So color magnitude is basically because that's what you're looking at. We call this the B minus V, we call that color. This is magnitude, so this is a color magnitude diagram. It was also first designed by two astronomers, one named Hertzsprung, the other named Russell, which is why we also often call it an HR diagram. So both are, it's two different names for the same thing. So the video looks like this. And you can download this video. You can also download the blackbody simulation that we saw earlier if you'd rather try and do as much of this offline as possible. So if you want to download the animations, then on that previous page you can click Downloads, go to All Simulations, and then download the apps. Then depending on whether you have a Windows machine or a Mac, you'll want to go through and do things. And you'll want to download the one that says NAAP Labs. That will have all the simulations that we need. Although I think if you do interactions, that gets you everything that they have. But the labs is all that you'll need for this, so that way you don't have to download quite as big a file. So, watching the video, there's no sound to it, but basically what the video does, it's a time-lapse video. So up at the top, we can see time up here. So remember, capital M means mega or million. So this is in millions of years. So right now, this is actually 1,257,270,000 is the age of the star cluster that we're looking at. And so you can watch the movie all the way through once if you want. It's pretty short. It's only 17 seconds. But basically, you can slide through the movie to stop at different times. And you're going to use that to answer the remaining questions that we have here. So if we go back and take a look at the manual itself, it's describing a special point, which is called the turnoff point, the main sequence turnoff point. So this diagonal looking thing is the main sequence. The point at which you start to see those dots, those stars, leave the main sequence, meaning that the stars themselves are changing their color and their magnitude. Something is happening to them to change that. And so that means when we plot them on here at a specific point in the cluster's life, we'll see them at different locations. You're going to use that video to go through and answer 3 final questions. For the first one, you're going to pause the movie when the cluster shown is 100 mega years old. Then you'll go through and write down for that turnoff point what the V magnitude is and what the B minus V magnitude is. So they're using slightly different labels here, but this is the same as what's shown in your spreadsheet. So this is the big capital V, and this is the capital B minus V. So if I were doing this right here for where I have it paused, then I would look over and say, okay, this is my turnoff point roughly, or maybe even a little bit lower. And I would go over and say, okay, so my V magnitude here is 1, 2, 3. And then for that same point, if I go straight down, try and approximate as best you can, I would say that my B minus V color is something along the lines of probably close to 0.5. So I would then mark down for 100 mega years that the M minus V M sub V, I said was 3, and those are all magnitudes. And then the B minus V, and you can write it either way that you want. It's the same thing as saying the M B minus MV, I said was 0.5 magnitudes. And then I'm going to repeat this for 1 gigayear, and so forth and so on. So I didn't actually do it for 100 megayears. The one I've got it paused at right now is almost 3 gigayears. Something more like that. But you will do it for 100 megayears, 1 gigayear, and 5 gigayear. Both of those numbers for each of those times. For the next question, you're going to go back and take a look at your spreadsheet, and specifically these 3 or 4 images of our different clusters. Based on what you see in the movie and based on how these look, you're just going to list in order which one of these 4 do I think is the youngest? So if I think that is M1, which is not listed here, but as an example, if I think M1 is the one that's the youngest, then I'm going to put M1 next. And then maybe I think M42 is the sort of next youngest. And so I'm going to list those 4 names in order from youngest to oldest right here for this question. And then for the final question, you're actually going to use the movie to try and estimate how old each of these clusters is. So for M67, the age of that one might be whatever. So you'll take a look and say, okay, so M67 looks like this. Its turnoff point is roughly here. So now I want to go through and move my movie until I get something that I think resembles that picture for M67. Then I'll write down that age. Repeat for the next one. For NGC 2571. What sort of age do I think best matches this picture? Then I'll repeat for this one, and then for this one. So to answer this last question, you will have each of these 4 clusters and with a corresponding age that you think that it is. So that gets you through the HR diagram lab. Please feel free to reach out to me and your fellow classmates on Slack if you have any questions, or especially me if you have any technical issues.